This is, guys, the abbreviation of the gas laws. So I want you at the beginning to basically put them in front of you and see which one you should use in this question, basically. And then by time, you get used to it. By practice, also you can also make flashcard for them. Okay, guys, let's do gases and chemical reactions. Unfortunately or fortunately, all of the basically chemistry questions, or most of them, they end up with stoichiometry questions. Do you remember we talked about stoichiometry? If you don't remember stoichiometry, I recommend you go back to the stoichiometry and then go back here, because we need to have a very good background in stoichiometry. Why? Because you already are learning gas laws, right? It's already new. So imagine if you don't know something like that you learned before, or we assume that you should know. So it would be double hard. Okay, so kind of, to be able to learn something very good, you need to basically know some of it very well first, and then by time, learn other stuff about it. You cannot just have so much information at a time to learn something. That's like when you said, okay, I'm done actually. Okay, so whenever you have a gas laws, basically this is the format you should do. Usually you should basically use the ideal gas law to find something from it, and then you should use the stoichiometry to relate the compounds to other compounds, because they give you chemical equation. If you remember, in a stoichiometry, they give you one compound, they ask for another compound. So you should always make sure you use the balanced chemical reaction and use the coefficients that are in front of each compound, the numbers that are in front of each compound in a balanced chemical equation to relate compounds to each other. So usually you should first find the mole from the ideal gas law, and then use the ideal gas law to find basically a specific thing from it. Or you should first use a stoichiometry to relate between compounds, and then use a PV equal to nRT again to find one of basically volume, pressure, or T or N from it. So anyway, you need to have a chemical reaction to relate the compounds to each other. So let me give you an example. How many moles of NH3 are formed from the reaction by 2.5 liter of hydrogen and 381 Kelvin and 1.32 atmosphere? So we first abbreviate it. And also they will give you a chemical equation. So whenever you see there is a chemical equation in the question, that's basically an alarm that you should use a stoichiometry. You know what I mean? So some lamp should be turned up in your brain that, oh, that's a stoichiometry question. So and one more thing that tells us that is a stoichiometry is that how many moles of NH3? Okay, the NH3 is here, right? But they gave me liter, temperature, and atmosphere or pressure of hydrogen. How I should relate them? You might ask, okay, maybe the teacher made a mistake here. So let me ask her. So before doing that, make sure you have done a stoichiometry. So you are going to first do the PV equals to nRT, PV equals to nRT, or this equation, N equals to PV divided by RT, which is another form of ideal gas law. So ideal gas law can be written based on what is unknown. So if your unknown is N here, So you can find it this way. So it's just, as I said, you divide the known numbers, divide by the unknown side, basically. So here we use N equals to PV divided by RT. I find my mole first. And then if you pay attention, we don't round until the end of the question. Just make sure. And then what we should do, guys, then we found the mole of H2 here. Okay, you might ask, okay, I found the mole of H2, but still they ask for me for mole of NH3. So now is the time to use a stoichiometry. You start with your given number, and then you use their coefficients to relate. So the 2 is a coefficient or the number after balancing. So make sure you have a balanced chemical equation. Make sure you have the same numbers of elements in the both sides. So then we have 3 mole of H2. Why I put the mole of H2 here? Why? Because they should cancel out with each other. Then I put the last one, which is what is asking for. So they ask for how many moles of NH3. So this is basically 2 sig fig at the end of mole of NH3. So again, you first find the number of mole, and again, then you're gonna use the stoichiometry to relate the compounds to each other. Depends what is given and what is asking for, okay? Okay, then before I basically continue to, I should also talk about something else, which is STP conditions. STP conditions are very important. What is STP condition? Please make sure write it down now when you see them. That's why I put them in red, because they are really important. When you see in the question, STP condition, they provide you some numbers. You might say, okay, there is no number here, but STP means some numbers. STP stands for standard temperature and pressure. What is a standard temperature and pressure? Temperature is always 0 centigrade or 273.15, and pressure is always 1 atmosphere. Okay, so whenever in the question you see a STP condition, very quickly write these two numbers, 0 centigrade or 273.15 Kelvin, and also 1 atmosphere. These two, write very quickly, you should write them down. The other thing that you should always write down, even if you don't need it, because you might forget about it. Write down 1 mole of each gas equals to 22.4 liter of that gas. Again, 1 mole of each gas at STP conditions, E equals to 22.4 liter of that gas. How we can use this? We can use it as a conversion factor. Conversion factor. So this is called, guys, molar volume of gas. 1 mole equals to 22.4. 1 mole equal to 22.4 liter is basically called molar volume. Molar volume of an ideal gas at STP. And as I said, these conditions are called standard temperature and pressure. Again, make sure whenever you have STP, write down these two, guys. These two red sentences are very helpful. Okay, so let's do a question on that, like molar volume. So calculate the number of liters of gas that form at STP. We have the equation again in this kind of, and also it might not be equation, but be ready for that. It sometimes, I have some question in the next slides that you kind of see what types of question it can be given. So it says we have 0.87 mole of CaCO3. Okay, so they gave us this, right? CaCO3, which is solid. They asked for a gas. So make sure, guys, in the gas laws, the gas questions, they always ask for something in gas form. You know what I mean? You know, like when if something should be related to gas, they should have a gas as a state close, next to them. So again, because here is give me something and ask me for something else, right? Gave me CaCO3 and asked for CO2. So I should use stoichiometry. That's a big lamp that should come up in your brain. So I start with the given number of CaCO3. I use the coefficients. Sometimes you are lucky, so it would be 1-to-1 ratio, as you see here. After we balance it, make sure it's balanced and is 1-to-1 ratio. And then I know that 1 mole of each gas, or here CO2, equal to 22.4. So you are right. They should write here at STP condition. They should tell you, guys. So I decided to write it later to kind of take your attention. So because here in the question they gave you at STP condition, they should tell you. Then 1 mole of each gas equals to 22.4 liter of CO2. So this will be the volume of the gas because it's asking in liter. Okay, so also another thing that I should tell you here is that, and is helpful, is that, okay, if in this question, usually this type of question is that they give you a gram or mole of an element, you should first make sure use the stoichiometry, use the ratios to convert to other, like here, and then they ask for the volume of the gas. Okay, when they ask for volume of the gas, you should use this. You should use this basically. There is no way to do that, to do something else. Okay, let's do some practice, guys. Question 1. If we have 20, so these are like the kind of wrap up questions. If we have 22 liters of nitrogen, always, even they don't tell you nitrogen, because it's gas concept, always they talk about N2. Okay, you should make sure that's the 2 nitrogen here, N2. So we have N2, 748, and compressed 2. So that's the state of 2, right? That's the stage 2 here. So that's the P1, that's the P2, and it says at constant temperature. So and I know that this is my V1, and they ask for the V2. So which one I should use here? So they gave me P and V here. So I have here 2P and 1V basically. What law I should use here? Tell me. Go and look at your gas laws. Here is the Boyle's law. So Boyle's law is basically P1V1 equals to P2V2, and the V2 will be 22.3. Make sure follow the sig fig rule, which is 3 sig fig at the end, and also make sure you have the same unit in the both sides. That's very important. And One more thing is that if you want to double check if your answer is correct or not, if you remember that pressure and volume are opposite to each other, because here my pressure is decreased from P1 to P2, so my volume should increase because they're opposite to each other, should increase from V1 to V2. So it's kind of double check. If you know what's the relationship between P and V, basically you can kind of recheck your answer. So that's the Boyle's law. Let's do the second one. A container has a 5.20 liter of a gas at this Kelvin, so the temperature, and LO 2. So this 2 tells me that that's my V2. And this would be, they ask for the what? T2. So we have the what law? Charles law. That's a Charles law. Make sure double check with the gas law table. Here I have a volume and temperature only. I have here 2 volume and 1 temperature. So the only gas law that has 2 volume and basically the 2 temperature is gonna be Charles law. So then I will substitute and the answer is 139 centigrade. So it's because it's asking for the Celsius here. So because I should put Kelvin in the gas laws, if you remember, I said that always make sure your gas should be in Kelvin when you put here. So because I already had the Kelvin, I got Kelvin. My output was Kelvin. So, but I should divide by 273 to get 139. So pay attention to read the question very carefully, guys. If you miss one part of question, if again your instructor is not nice, they might, kind of don't give you, most of the, usually they should get like most of the answer if you don't, even if you don't answer like in Celsius. But sometimes some teachers are strict, and so you should make sure that you convert to what is asking for in the question. So let's see, what is the volume of 25 gram of nitrogen at STP? What was STP? STP is 1 atmosphere and 0 centigrade, or 273.15 Kelvin. So, and we have 25 gram. Do you remember what I said to you? And I saw there is another one. 1 mole of each gas equals to 22.4 liters. So please write them down right away. So what should we do when we have a 25 gram of something or gram of something? We convert to mole first. So I convert to mole first. I convert to mole. Then I should use the basically 1 mole of N2 equals to 22.4 liter to get that. So not always you should use the 2 rules, you know what I mean? It depends. So if they ask for volume in the question, usually this works. This 1 mole equals to 22.4 liter, or a molar volume of the gas. Basically conversion factor always works basically. So I make sure 2 sig fig, which is basically the same as 2 sig fig in the given number. So let's go to the question 4. A gas balloon has a volume of 106 liter when the temperature is 21 and the pressure is 731 millimeter mercury. What will be its volume? So will be. So if also make sure, if you pay attention, when you have will, always also you talk about this basically a stage 2. So what will be? So I know that this is gonna be my stage 2. This is a stage 2. Which one I should use, guys? They gave me stage 1 here, 106, which is the volume, depth, temperature, and also the pressure. And they basically gave me for a stage 2 temperature and pressure. So they gave me 5 knowns and they asked for 1 unknown. Which one I should use? Which gas law? Combined gas law. Combined gas law. So I'm going to substitute the numbers, and again make sure the side that is known to the cross divide by the side that is unknown in it, and this gonna be 3 sig fig at the end. Because my number was ambiguous, I made it to scientific notation. I recommend you always to your last number to be in the scientific notation. One more thing, you might ask, okay, why you don't use 273.15? So basically it depends on the instructor again. I don't really basically follow that 273.15, but some instructors follow the exact basically 273.15. But if in the question they gave you Kelvin like 273.15, use that one, okay? But it's not, I'm okay if you put 273 by itself, okay? So what volume of NH3, that's the question 5. What volume of NH3 gas at STP is produced using this much of Mg3N2? Okay, guys, we answered this question in the previous slide. So it's asking for volume. What should I do if they ask for volume? Molar volume, right? Molar volume, or 1 mole equals to 22.4 liter. So here I have a gram of this compound. So they gave me gram of this compound and they asked for me for the volume of NH3. So it's huge from here to here, right? How I can go from this compound to this, right? That's the stoichiometry again. So I'm gonna make sure it's balanced. Is it balanced? It's not balanced. So I'm gonna balance it. Then I start with my given number, which is gram. What should I do? Convert to mole first. Convert to mole first. Then I use a coefficient to convert the mole of the magnesium nitrate to ammonia. And I'm going to use molar volume because it's asking for volume here. Then this is going to be my volume of the NH3 in liter. If they do not ask in milliliter or liter, you can either put in liter or milliliter. But here we already have the liter. I just kept it in liter because it's easier. You know what I mean? But if they emphasize what you need, you should make sure convert to the unit that is asking for, okay? So let's go to the question 6. What is the density of carbon dioxide? Okay, you might ask, okay, they ask for density here, and STP. What is STP? 1 mole equals to 22.4 liter of the gas. So I know that D equals to M over V, and I know that 1 mole of carbon dioxide, it depends on your gas. Here I have carbon dioxide, so you look at the gas and find the mass of the gas, which of 1 mole of the gas, which you see, you can find it in the bottom of each, basically, you can find the atomic mass of each element in the periodic table and then add them up. When you add them up, you get a 1 mole of that gas, basically. That's the 144 gram per mole, and I divide it by the basically liter of the gas. So because I'm dividing this, and I guess basically 2 gram per mole. Gram per mole. Okay, so let's go to the question 7. So in the question 6, you should make sure what gas they gave you. Find the 1 mole of the gas from the periodic table. When adding up the atomic masses, you get the basically molecular mass. So this is how you do it. Make sure you find the carbon dioxide is around 44 gram per mole, and I divide it by the 22.4 liter, which is in 1 mole of the gas. That would be the density. So a metal tank contains 3 gases. If the partial pressures are these, find the total. So which one is that, guys? That's the Dalton's gas, right? Dalton's law of partial pressure. So I'm gonna add them up, the partial pressures, and it's gonna be, the only trick that might be here is that they might give you in different units. Make sure you pay attention that the units are the same. In the last question, they gave us amount of NH3 in the volume, temperature, and pressure, and they ask for HCl. So they gave us information about NH3. They ask for the gram of HCl here. So what I'm gonna do, I'm gonna use ideal gas law. Okay, that's the only logical answer that it can come to my brain, because they gave me volume, they gave me temperature, and they gave me pressure. The only one that is kind of suit for this is PV equals to nRT, or ideal gas law. Then I find the mole of NH3, and I'm going to use the coefficients to relate between, make sure you have a balanced chemical equation to relate between NH3 and HCl. And then you find the gram of HCl. So first you should use ideal gas law, and then because it's asking for the gram of HCl here, so you should use the coefficients to convert between the this compound to HCl. Okay guys, that's it for this concept.